Hey everybody. Today what we're going to be doing is just working on connecting everything we have. So today's day is kind of a putting it all together day. What today is going to act as is a great review of everything that we've talked about up to this point in our cycle. So us working our way through, trying to draw together the idea of slope from a graph and an equation, the intercept, how do we graph that? Can we build the equation from the information? Can we deal with first differences and independent and dependent variables? It is a collection of everything. So what you see on the screen is there is a big chart for us. And if you look down the left side of that, you're going to see that I have given you information in different forms. So perhaps you end up getting a graph being given to you. Perhaps you end up being given a table of values. Maybe we end up giving you the equation. Or perhaps we give you information, but in word form. So could we end up dealing with it as a situation, an application? What I would like to do today is to take each of those different forms that we have and can we break down the information from it? Looking across the top row, what we're going to examine is, can you deal with, is that relationship linear, nonlinear? Can you determine the slope or rate of change of that problem? Can we go through and deal with a vertical intercept? We can't always say y-intercept because our vertical axis might not be a y-axis. Can you classify what is the dependent and independent variables? What do they represent? And then finally, if it is linear, could you build the equation for it? Okay? That's what we're going to work our way through today. What I want you to do is to start off just on the top row, and we'll take that one as a little bit of a warm-up. We'll see what we can do based on our background. So I want you to take a look at that top row where I've given you the graph, and I want you to try to fill in everything on that row that you can, and then we'll check back in together. Okay? Pause the video now and give it a shot. Okay, we're back. So I want to jump in and I want to play with that. I'm going to zoom in on that top row. Okay, so what we have then is that top row or maybe top two rows kind of zoomed in. I want to take a breakdown and start walking our way across. By no means did you have to fill in that row in the order from left to right. I'm just going to do it because it doesn't really matter what order I fill it in. So if you didn't fill it in that order, that's okay. However, there will be some of those properties that we've been asked to find that are dependent on the other properties in that row. You'll see what I'm talking about as we get going. So the first thing, I am hoping that everybody said that that is a linear relation. You can see you've got a line on that graph. What is the slope or rate of change for that line? Well, for me to do that, I need to examine my graph closely. So I am going to zoom in on that graph so that we can take a look and determine our slope. I know that my slope is always rise over run. So I can pick any point that I have on that graph, and maybe I just go to this first point that I'm circling here. Okay, I'm going to just delete that a little bit, but you can see where I'm focusing in. If I begin to move from that point, then I will notice to get to my next point, I'm going to move 2 grid lines to the right. Don't count grid lines. Look at your scales. So if I look down at the bottom to see on my horizontal scale, I notice that I only went across 1 unit. 2 grid lines, but it was only 1 unit. Now I go up, and if I look at my scale on the left side, up 1 grid line would be 5 units. Okay, I'm going to now zoom back out And for us to be able to go through and deal with that, I should be good that my slope is always my rise over my run, and then I will simplify. And hopefully we came up with 5. Now, I didn't have to pick those 2 points. Since it's a line, I could pick any 2 points. You just make sure that your slope is reduced. Okay, my vertical intercept, I got to zero in on my graph again. Where does my graph hit the vertical axis? You can see me circle it there in blue. And if I count up to see what units that is, that would put me at 15 units. Now, what's really, really important is that I need to go back to slope for a second and just notice that I did not declare that as a rate of change. Because my problem has a context to it. You notice my vertical axis says cost in dollars, and I don't know what I'm measuring in terms of the number of on my horizontal axis, but it is a quantity. Then really what I have is $5 per item, per unit. Okay, now that we've done that, I can jump over to dependent and independent variables. And as I take a look at that, my independent variable is always on the x-axis or the horizontal axis. So that is n for whatever that represents. And then my vertical axis is my dependent, and that would be maybe a C for cost. Now, we can jump into the last column. That last column asks me to figure out the equation if it was linear. So I go back, and yes, I've confirmed it's linear. So my equation is always going to take the form y equals mx plus b, or I should say I can write it in that form. And so my dependent variable is going to equal my slope times my independent variable. Oh shoot, it's not an x, it's an n. Really common mistake. And now add on my fixed amount or my vertical intercept. There we go. So you take a peek at how well you did on that top row and see how well we matched up. See if there's anything you need to fine tune. Because now what we want to start doing is we want to start doing every single row. Every single row. So what I'm going to ask you to do is to try to fill in the rest of that front page. The rest of it. I'm going to go through and pop up some solutions to each row one at a time. But I want you to try to complete everything as if it was a test right now. No looking at your notes. No working with a buddy. You guys try to draw all those connections you can. Okay, so let's tackle that next row. What if I gave you a table of values? Okay, I want you to pause it now. Okay, we're back. So, first thing asked me to figure out linear or nonlinear, and honestly, I can't answer that yet. For me to answer that, I need to look at first differences. So, I am calculating the differences in my y values. If I look at my table, I went up 100 there. Since it is positive, I don't need to write my sign. I then notice that every single time I am moving from one point to the other point, I went up 100. That is not enough for me to be able to say linear. Recall, I have to look and see, am I also going up by consistent amounts on my independent variable? And yes, I am. So because those amounts are the same, I can now confidently say linear. My first differences are actually me calculating my slope. So to calculate my slope, my distance went up 100 and my run was 10. And so when I calculate or simplify, I get a slope of 10. I have a context to it that is going to end up being 10 meters per second. If I look in my table, I can read my vertical intercept. Right there is my vertical intercept, and I know that it's my vertical intercept because my time value is 0. That means that my vertical intercept is 100. Okay, my independent is time, and when time is included, it is almost always your independent variable. My dependent is distance. Now we need to write an equation. Since it was linear, I can. And so I have my distance is going to equal my slope times, and maybe I use the letter T for time, plus my vertical intercept. Okay, hopefully that one went well. You figure out where we made any mistakes, where we need to make some corrections. If you need to rewind back, watch something again, please do so. But here's another opportunity to pause the video, and if there was anything you need to correct or anything you were not able to fill out on the rest of the page, go back and try it now on your own. Okay? Pause the video now. Okay, we're back. This one, I gave you the equation to it. So we should be able to recognize that, yes, that is linear because the exponents on both variables are 1. So that tells me that that is a line. What is my slope? Well, this one's actually really easy. I can put that together and say 2 because I can read my slope from my equation because my C is isolated. What does that make my vertical intercept? I can also read that. That is 5. My independent variable would be N. My dependent would be C. And I do not need to write the equation because the equation was given. Nice. Again, hopefully that one went well. And now you have an opportunity to finish off that last row. If there was anything that you left blank or anything that now you would want to correct, do it on your own. Okay? Pause the video if you need to go through and make any corrections. Otherwise, you're coming through with me to check out a solution to the last row. Okay, I am just going to scroll that up a little bit. We should be good on what we're filling in on each column. Danny's gym class is running a dodgeball tournament. They charge $8 to enter a team and $2.50 per person. Well, let's say that I just took that information that was given and I did not fill it in left to right. I just kind of filled it in as the information was given to me. Okay. They charge $8 per team to enter. 8 to enter. That's our fixed amount. That is our vertical intercept. They then charge $2.50 per person. There is my rate of change. Since I am changing the same amount for every additional person I sign up, it is linear. It's not like I'm charging $2.50 for the first 5 and then $1.50 for those afterwards. It is the same amount every time. That would make possibly my independent variable being like an N maybe for the number of people. And that would make my dependent variable probably like a C for the cost to enter the team. I should be good to be able to build my equation now. My total cost is $2.50 per person with the fixed amount of $8. Okay, you now have the ability to look over the whole sheet and see, are we able to draw in and make those connections between graph to table to equation to words, and hopefully everything's coming together. Okay, what I want to do now is instead of me asking you all those properties in a way, what I want to do is I want to start looking at all the different ways we could give you that and now drawing the connection between those. What I want you to do is turn over your page. So what you should be able to see then is in question A, B, C, and D, it is the chart that I just gave you, but it doesn't really have the structure to it. So can you go through and figure out linear, nonlinear, slope or rate of change, vertical intercept, independent, dependent variables, and then write the equation if you can, if linear. So we're going to go through super fast. This backside of your page now should be an opportunity for you to use this almost like a practice evaluation. If I was to throw this information at you in table, graph, words, equation form, would you be able to convert it and find all that important information? Okay. Same thing as the front. I want you to try to do the whole back all in one go. And then I'm going to go through and walk through the solutions to each one. Okay, you pause it, give it a shot. Pause it now. Okay, we're back. So I'm going to use the numbers to identify what I'm finding in each case. If I'm starting off with problem A, that's asking me, is it linear? Is it nonlinear? I'm just going to zoom in a little bit on A so that we can kind of focus in on that one. Well, for me to come up with is it linear or nonlinear, I need to examine first differences. So I notice that I went up 20, and up 20. Over here, I notice I went up 10, and 10, and 10. It is the same movements from point to point. And so therefore, I know that my number one is linear. The act of doing that, actually, let me keep my Roman numerals so they're all consistent. The act of doing my first differences actually gave me my slope. So I know that my slope is rise over run. So it is my 20 over 10. My slope is 2. And you could write it as your $2 per person. I need to find the vertical intercept, so I'm going back to my table and I am looking for any point where my independent variable is 0. And there's where I find it. And so I know that my starting amount is 100. So it cost me $100 to just rent whatever I'm renting, and then $2 per person on top of that. What would be my independent, dependent variables? Well, I think in this case, my number of people might be an N for independent, and my dependent would likely be a C for cost. Can I write the equation? Absolutely I can. Because it's linear, I can say that my cost is my amount per person plus my fixed amount. And there we go. So hopefully we're feeling more comfortable with it. We're doing a little better. We're moving a little faster. We're able to draw those connections a little quicker. Okay, here's your opportunity to pause again if you need to. Otherwise, you're coming along with me for solution 2B. So I've just zoomed in on B here so that we can go through and we can find everything that we need to. So first off, we had to find linear, nonlinear. I think we're in deep trouble if we can't see that that is linear. Now I do need to find slope. Well, 2 points have been identified on my graph, which makes that a little bit easier for me. So if I was to move according to slope, then that's going to tell me move from A to B. I look on my scales and I notice that each grid line is worth 1 in every direction. So I went across 3 and I went up 2. That makes my slope 2/3. Okay, next thing I needed was my vertical intercept. Well, for me to go and find my vertical intercept, I can look over here and I notice it looks like it's at -1. I want to confirm that. So what I'm actually going to do is I'm going to move backwards according to slope. If I went backwards 3, then my slope says that I should go back down 2, and I do get a little confirmation that that graph actually has a vertical intercept of -1. I'm not just trusting my eyes that it went through that point. Okay, I need my independent, dependent variables. Well, neither of my axes have been labeled with any application. So my independent is x, my dependent is y. And then finally, can I build the equation of that? And yes, I can, because it's a line. I know that my y has to equal mx plus b, so my slope times my variable, and add on my y-intercept, so I'm going to subtract 1. And there's my equation. Nice. Okay, same thing. We have another opportunity. You pause the video now, make any corrections, or you're coming along with me to check out a solution to C. Okay, I have zoomed in on C a little bit. Anton pays $7.99 for Disney Plus every month. So what does that turn into for us in terms of all of those properties? Okay, well, since we are paying the same amount every month, since it is not changing, then that makes that relationship linear. I have been given my amount per month, so I have been given my rate of change. My slope is 7.99. What does that make my vertical intercept? Well, there is no fixed amount here. Like, I didn't pay a certain amount to sign up for Disney Plus, then an amount per month. So my vertical intercept is 0. My independent variables, dependent, they haven't been defined. I will have to likely define it. My independent would probably be something like n, maybe, for number of months. And probably my dependent would be something like C for total cost. Can I build my equation? Yes, because it is linear. My cost is my amount per month. Please don't write +0 on the end. But we do know that there is a vertical intercept of 0 or no fixed amount. But that is horrible form. Just leave it as C equals 7.99n. Okay, finally, we've got D, our equation. I should be able to slide across now and put up a solution to D, and hopefully we will all match up with this final example. Is it a line? Yes, because you see in the equation, the exponent on both variables is 1. What is our slope? I can read that slope. It is the coefficient on my independent variable, so my slope is 40. What does that make my fixed amount? Well, my fixed amount, or my vertical intercept, is going to be 300. What would my independent, dependent variables be? Well, they're written in the equation. My independent is my M, my dependent is my C. And I don't really know what those represent, but those are the variables in the equation. And I do not have to give an equation. One has been given. Okay. Hopefully that was a good way for you guys to kind of see the connectedness and you're feeling more confident working through it. One last example to go. Okay, you can see the final page, and there is our one example given in words with a partial table, a big grid. You have been asked to go through and take that relationship in words, construct a table of values, complete a graph, write the equation that would fit that, And then don't miss out on that last problem at the bottom. When will Chris's drone hit the ground? So I want everybody to go back up to the very top and give this application a read. Okay, I'm going to read it out loud, make sure we're all good. Chris is flying a remote drone. It starts at a height of 1,800 feet, that is 1,800 feet, and descends at 100 feet per second. If h is the total height and t is the time in seconds, fill in the following. Okay, I think I'm going to fill in the table first. That problem, that information, gives me some stuff right off the bat. It tells me that at time 0, I start at 1,800 feet. It starts at a height. So I can complete 1,800 feet at t equals 0. Now, I can go through and I can calculate the rest. If I am descending, so going down at 100 feet per second, then if I look at my table now, and I notice that my next point in my table is for at 2 seconds, then I must have gone down 200 feet. So if I go down 200 feet, there's a 1,600. And if I follow the pattern in my table, another 2 seconds go by, so I go down another 200, another 2 seconds, down another 200, another 2 seconds, and there is our pattern. Now, I don't know what order you want to deal with. Maybe you didn't deal with the table at first. Maybe you said, hey, I know how to interpret that as an equation. I know that my height would start at a value of 1,800, but I am going down 100 for every second that passes. And maybe you build your equation that way. Then maybe you use the equation to go through and build the table. Either way is good. Remember, there's connectedness with this. Okay, I'm going to deal with the problem at the bottom because since I have an equation, I could use that to solve, and then I'm going to go through and use my graph to confirm it. So I'm going to just zoom up a little bit or scroll up a little because the question asks, when will Chris's drone hit the ground? And what that is actually asking me to find is when is the height 0? And so if I took that h equals 0 and I sub it into my equation, I've now built an equation just for t, and I can solve that. Maybe I want to get rid of that t term because it is negative, and I want to think of it being on the other side. So to get rid of a minus 100t, I'm going to add 100t. And then to go through and get my t all by itself, I'm going to take my 1,800 and divide it by 100. And that means that t is going to be 18. Now, because this problem has a context, I need to put units on that. T is being measured in, if we look back up, seconds. And there we go. So when I go through and I produce my graph should confirm that I get to a height of 0 at 18 seconds. Okay, let's build our graph. So on my vertical axis, I need to have my height. And on my horizontal, I have my time. Remember, time pretty much always goes on my horizontal axis. Now, I take a look at my scales. My time scale is pretty decent. I look at what I had to solve at the bottom, and that was 18, but that doesn't really impact my scale on my horizontal axis. I think I'm going to make every grid line just be worth 1. So if I start out at 0, then 2, 4, 6, 8, 10, 12, 14, 16. So I should be good that my graph is going to hit the bottom just off of my grid. Okay, if I go vertical on that though, I need to make sure that I get all the way up to 1,800. So if I count my grid lines and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, if I make each grid line only worth 100, I won't be able to get up there. So I think what I'm going to do is make every grid line worth 200. Okay, that makes this grid line 200. The next one 400, 600, 800, 1,000. 1,200, 400, 600, 800, 2,000. And now I have plenty of room on my grid. Notice my scales are consistent for every grid line. There's no changing scales on an axis. Okay, I can plot my table now. So I'm going to take that first point, which was at 0 and 1,800, and plot that there. Now I need to go over to 2 and 1,600, 4 and 1,400. Oops. I mislabeled my 1,600. There we go. That's better. My 4 at 1,400. My 6 at 1,200. And as you are plotting all these points, we know that this should form a line because the problem gives us a line. We can see in our first differences that we went down 200, up 2 seconds. So I get confirmation that my slope is negative 200 over 2, negative 100. I have a consistent slope everywhere. Now, with those blue points, I have enough that I can now go through and I can graph. So I'm going to take my straight edge and I'm going to line it up and I'm going to be accurate as I can be. The only reason why I don't want that to be accurate is because of human error. And now I can connect all of those points because I can have fractions of a second. I get my line. I cannot put an arrow on the left side of that graph because time does not go negative. However, my graph would extend off my grid to the right, so I will put an arrow on that end. And that's a pretty sloppy arrow. A little better. There we go. There is our table to our graph to our equation to solving for a particular situation in the application. Okay, I am hoping today acted as a very good culminating activity for us. It should have acted like a pretty good review. Your job, jump in, get practice. You make sure you are good at putting everything together. Okay, good luck.